Welcome to this channel. In this video we'll be talking about set proving. This is not the first video on set proving. If you have not watched the first video, please try to do so. Now, when talking about set proving, there is no way you want to talk about set proving without talking about the laws. Example are commutative law, associative, distributive, identity, double complement, etc. Now, let's look at this example. A symmetric difference B intersect A union B is equal to what? A symmetric difference B. Now look at the instruction given to us. They said if A, B, C are subset of X where X is the universal set, prove that A symmetric B intersect A union B is equal to A symmetric difference what? Difference B. Well, before I go into the proving, let's do a formal proof. So let's start a formal proving. We are told that A, B, C are subsets, right? Okay. Let's say our universal set is 1, 2, 3, 4. Then let's say our A, because they are subsets, we're going to remove them from this 3, 4, and let our B to be 1, 2. Okay, now A symmetric difference B is the same thing as saying A minus B union B minus A, right? Okay, what is A minus B? Element present in this that is not here, that is 3, 4 union B minus A, that is 1, 2. Okay, when you union them together you have 1, 2, 3, 4. Okay, now what is A union B? That will give you what? 1, 2, 3, 4. Then if you perform the operation which is A symmetric B union intersect A union B, you have the answer to be 1, 2, 3, 4. Okay, maybe you are not clear with this. Let's try to do another formal proof before we go into our proving. Let A to be 1, 2, 3, and let B to be 1, 3, 4. What is A minus B? That one will give us 2. B minus A will give us what? 4. Then A, this union B will give us what? 2, 4, right? Now what is A union B? A union B is 1, 2, 3, 4. Then if that should be the case, what is 2, 4 intersect 1, 2, 3, 4? You notice that it is still the same thing as saying 2, 4. That means our answer is what? Correct. Now let's go into the proving. Let's see if we are going to have this answer. Okay, let's go. A symmetric B intersect A union B, A minus B union B minus A in a big bracket intersect A union B. That is just definition of set difference, sets symmetric. Okay, let's use commutative law. A union B intersect B bracket A minus B union B minus A. Okay, that will be A union B intersect A minus B. We are using set distributive now, distribution. A union B intersect B difference A. Okay, after this, what's the next thing for us to do? We want to use set difference here. A union B intersect A intersect B prime. That is the definition of set difference. Okay, A union B intersect B intersect A. That is the definition for what? Set difference. Okay. The next thing for us to do here is to okay, let's pick this thing one after the other. Let's call this one I1 and let's call this one I2, so that it will be very easy for us to solve. Okay, now I1 equal to A union B intersect A intersect B prime. Okay, now what is the next thing for us to do in this at this particular junction? We can use this thing, we can solve it in two ways, but I'm not going to use the second way. Yes, because it will be very short. Okay, now let's continue with a normal problem. So from here, let's try to use another associative law again. So that would be A intersect B prime intersect A union B. So that would be A intersect A union B intersect B prime intersect A union what? Union B. So if you remember, the law here is what? Absorption law. This one will give us A. If you check the video on set proving 1, this is absorption law. This one will give us A intersect. Don't forget that A union B, because we are having two sets here and they said it is a subset of what? Of X. That means A union B will give us what? Universal set. So that will be B prime intersect X, which is universal. So we have A intersect B prime. So our answer is what? A intersect B prime for I1. Okay, I2. Now the reason why I said I don't want to use that method then is because if you check this one, A union B intersect A intersect B prime, you can see this one is universal. The intersect, we have what? We have the result. Okay, same thing applies here. Let's use that method here. Since A union B is equal to X, then X intersect B intersect A prime will give us what? B intersect A prime. So our I2, we have what? B intersect A prime, which is the same thing as saying B minus A. This one is the same thing as saying A minus B. So, and don't forget our point here. So I1 union I2, that will give us what? A minus B union B minus A, which is the same thing as saying asymmetric difference B. I hope you understand this thing. So all thanks to our subscribers and to our amiable sponsor Onifade Emmanuel. We really appreciate you, sir. Thank you. God bless you. We don't even know what to say. Like, we really appreciate you. God bless you abundantly, and God will continue to use you for the work. Thank you, sir. God bless you. I really appreciate it.